Hello everyone. Today we are starting with a new topic, Boolean Algebra. This presentation will cover the fundamentals. We'll explore the concepts of Boolean variables, the different operations that can be performed on them, and some basic laws that govern these operations. Let's begin by understanding what Boolean variables are. By definition, these are variables that can only take on two possible values, true or false. In the context of computing and digital logic, these values are often represented as 1 for true and 0 for false. So, a Boolean variable can either be 0, which is equivalent to false, or 1, which is equivalent to true. Now, let's explore the fundamental operations in Boolean algebra, starting with the AND operation. The AND operation, also known as logical AND, is a binary operation, meaning it operates on two inputs. The symbol used to represent the AND operation is an upside-down V, or simply a dot. So A and B can be written as A upside-down VB, or a dot B. A truth table is a table which shows all possible input combinations and their corresponding output for a logical operation. Here is the truth table for the AND operation. When A is 0 and B is 0, A and B is 0. When A is 0 and B is 1, A and B is 0. When A is 1 and B is 0, A and B is 0. And finally, when A is 1 and B is 1, A and B is 1. So, the AND operation results in 1 or true only when both inputs are 1 or true. Next, let's look at the OR operation. The OR operation, also known as logical OR, is another binary operation in Boolean algebra. The symbol used to represent the OR operation is AV, or a plus sign. So A or B can be written as AVB, or a plus B. The truth table for the OR operation is as follows. When A is 0 and B is 0, A or B is 0. When A is 0 and B is 1, A or B is 1. When A is 1 and B is 0, A or B is 1. And finally, when A is 1 and B is 1, A or B is 1. Therefore, the OR operation results in 1 or true if either or both of the inputs are 1 or true. The NOT operation is our final operation. The NOT operation, also known as logical NOT, is a unary operation, meaning it operates on a single input. The symbol to represent the NOT operation is a, or an apostrophe. So, not A can be written as A or A apostrophe. The truth table for the NOT operation is simple. When A is 0, not A is 1. Conversely, when A is 1, not A is 0. The NOT operation simply inverts the input value. Now, let's move on to the basic laws of Boolean algebra, starting with the commutative laws. The commutative laws dictate that the order of operands does not affect the result of the operation. For the AND commutative law, A and B is equal to B and A. For the OR commutative law, A or B is equal to B or A. So, it does not matter which order the variables are written. Next are the associative laws. The associative laws state that the grouping of operands does not affect the result of the operation. For the AND associative law, A and B within parenthesis and C is equal to A and within parenthesis B and C. For the OR associative law, A or B within parenthesis or C is equal to A or within parenthesis B or C. So, when performing a series of AND OR operations, the way in which the variables are grouped together does not change the outcome. Lastly are the identity laws. The identity laws define the behavior of Boolean variables when combined with the identity elements for the AND OR operations. For the AND identity, A and 1 is equal to A. This means that if you and any variable A with 1, the result will be the variable A itself. A and 0 is equal to 0. Which means that if you and any variable A with 0, the result will always be 0. Therefore, the identity element for AND is 1. For the OR identity, A or 0 is equal to A. This means that if you or any variable A with 0, the result will be the variable A itself. A or 1 is equal to 1. Which means that if you or any variable A with 1, the result will always be 1. Therefore, the identity element for OR is 0. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.